you've never seen before. All right. So here it is. It's Monday morning, and I'm lying in bed, looking at my watch. Can I get up yet? Can I get up yet? I just couldn't wait to get the day going, to get the real, filming, the tour, the whole steel mill experience.
Because here in the United States, about 72% of all steel is manufactured using what's known as the EAF route, or the electric arc furnace. And that's a technology that allows virtually 100% recycled steel as the input. It's highly efficient, produces a strong product, and when you compare the energy savings and the reduction in carbon gas emissions from the electric arc furnaces to the basic oxygen furnace or integrated, significant savings. So it's a preferable process.
And everybody's right. We're going through the checklist. Do we have the drones? Do we have the backup batteries? Do we have the microphones? Do we have the tripods? Do we have all the cameras? And you were checking, everybody's double checking with everybody. So we go into the one conference room and we drop in the gear, and we're getting everything ready, getting everything out, and make sure, again, taking off our rings, taking off our watches, taking off our necklaces. There was a sense of adventure that here we go, and you had all your gear, the safety gear, and we were going in, and here we go. We enter the mill at the same place we entered on Sunday, and right where the slabs are coming out, and boom, sure enough, as soon as we walk in, another slab goes in, and in the heat, you're feeling it. So you go up one set of stairs crossed over where the reheated slabs come out. You go back down the stairs, and then we have to go outside and then up 4 flights of stairs, and we're like, what the heck, where are we going? And you're doing nothing but humping up and down the steel mill to try to find where we're supposed to go. And at this point, I'm just lost because my excitement level is at an all-time high. And you're hearing the noises. So you're like, wow, I am part of this. You are. What you're seeing is almost apocalyptic. So all these safety measures, then you enter this room, this control room. What am I getting myself into? Where's this? What is this noise? And you got all these computer screens, and you're like, wow. It's like you're actually part of it. You're like part of the movie. You're part of the story. But I'm going to tell you, you walk into the control room at the steel mill, and it's unlike anything I ever witnessed, because the vision outside these glass, because it's orange, and then there's fire, and there's sparks, and there's red, and you're just like, whoa. This ginormous flame, and it's these pictures that I have that share, it's just this apocalyptic. Oh my God, what just happened?
Oh, this wasn't bad at all.
Thank you, sir. We really appreciate it.
Thank you.
Appreciate it.
I didn't plan for this.
Nolan Nelson. Yes, metallurgist. Basically, metal scientist, metals engineer.
Oh my God, what just happened? What just happened? Oh my.
So the scrap comes in and it's sorted by grade and type. The crane operators in the yard will go to the right scrap piles, and for that scrap recipe for that grade we're going to make, pick X tons of this scrap, X tons of that scrap, and layer it in our scrap bucket. So if you look at what appears to be the finer shredded material, be shredded automotive. If you look at some of the larger material that has bars and beams and other things, that'd be your heavy melt type product. And we'll pick it up, they'll get it into the scrap bucket. That allows them to kind of manage the weight that they're charging into the bucket.
I look out here, this is my world. Metal recycling, scrap, cut grade, shredded, bundles in the back. This is my world. This is what I do every day. But it arrives here at the mill, and there's a whole new world that happens here. Tell us about it. Well, when it arrives at the mill, whether it's in the truck or rail, as you can see, some of the rail comes directly under the cranes to be loaded into the charge buckets. Other goes to the inventory side where it's unloaded and put into the different grades of scrap. And truck is dumped on that side also for inventory. And then it's backloaded into the cars when we need it on this side under the charge cranes.
We'll get 80 to 90 tons of scrap into our bucket, typically.
So there's a bit of a chef aspect to creating a melt at a mill. Am I right? Yes. You gotta use a little bit of this and a little bit of that, right? Yes, sir. Who's the genius behind that? Are you the genius behind that? I play with it.
And we'll bring that into the melt shop, and the operator will pick it up with the crane, and then they will swing it over the furnace. And so we have a twin shell electric arc furnace, or EAF, and the roof will move out of the way, and the bucket will drop the charge of scrap into the furnace, and then we'll put the roof back on and then lower the electrode in. The electrode is the big graphite column in the middle. We have one electrode on a pivoting mast arm. It's about a 30-inch diameter graphite electrode, 120 megawatt transformer outside, so it's like a big stick welder. You're running electricity through that electrode. It runs through the scrap. That's going to give you your electric resistance heating.
What's the temperature of that electrode? I couldn't tell you because I've never shot it, but I've heard theoretically it's around 25,000 degrees.
And melt that scrap down from a solid to a liquid. Because we want to turn that solid into a liquid so that we can refine it, and then we can alloy it or add our ingredients in and make the grade of steel that we intend to.
It's interesting when you think about the history of the recycling industry. It really dates back to biblical times. There are passages in the Bible that speak to pounding swords into plowshares. And so mankind has always realized the value of finite resources and that they should be used, not discarded. And when we think about it for a minute, we consider settlers who came and settled the North American landscape in the early days of this country. If they had a horse to throw a shoe, they didn't discard that shoe. They saved it, and they traded it back into the blacksmith for credit, always. I've got a great cup in my office from a reader who sent it to me. The animated commemorative for 150-year anniversary of their company. And it said, from furs to scrap, we've been trading for 150 years. And that's the essence of the recycling industry. It really has very, very deep roots in history.
So as we finish seeing this whole process in the control room, Randy, our guide, takes us, well, Dave, the safety, but Randy is the mill guy who was telling us, explaining everything. So he takes us down and goes, come on. And you're following Big Randy, and you're like, he's not saying anything. He just says, come on.
And then when they tap the furnace, A lot of that is concealed and contained, where it's a bottom tapping furnace, eccentric bottom tapping, so it'll drain vertically into a ladle, which you called the cauldron there, which is a good description. And the ladle is just a big metal vessel lined with a refractory brick. It's mostly a magnesium oxide brick with a real high melting point. And so we'll start with a warm ladle so that we don't shock it, and we add hot steel to that. So when we tap the furnace and it's around 2,900 degrees Fahrenheit, that'll fill a ladle full of steel. And for us, that heat size will be about 150 to 155 liquid tons of steel.
And so you get down to the floor of the furnace room at the melt shop, because you see the two furnaces and you're on the floor, they're looking, they're stopping. Okay, we can go. Come on. And you're like hustling because you're just feeling, nah, this isn't a place for a human. Whereas the backside of the furnaces, and there's these guys in these silver suits, these fire retardant suits with these helmets and these shields on. And we were being explained that these guys are going to check the refrac inside the furnace to make sure it's okay. The refrac is what guards the steel on the inside.
So what we've done at the beginning is basically taken scrap metal, steel scrap, to get us a liquid base to start. And from there, that's kind of our building block or our dough or whatever you want to call it for our recipe to send over and refine.
So these guys in their silver fire retardant suits are there to inspect the refrac inside the cauldron, the furnace itself. And what they do is they get in there and they got these big long things of steel and they're poking around trying to, what they're doing and what they're looking for is, I don't know, but I know they have a very important job. So we're standing there and all this commotion's going on. Then Big Randy looks at me and says, "John, come on, here, put these gloves on, put this face shield on, follow me." And I don't know what the hell I'm doing. We go up these stairs, we're going towards the furnace, and he goes, "Take a look." So there I was standing there, looking inside this furnace with this incredible adrenaline rush. And then all of a sudden it dawns on me, I've never been so doggone hot in my entire life. The heat. Justin, my cameraman, was next to me. His camera, and within 5 seconds, shuts off because of the heat. And it's just like, time to go. So we turned around and we left, but it was just an incredible experience looking inside the furnace. Something I never thought I'd ever be able to do. Nothing I could say at that moment. I was speechless. This is 24/7, it doesn't stop, and without recycled iron and the supply chain that we provide for a steel mill, you don't have new steel. Without this, there's no steel. So this is happening 24/7, like I said, and these magnets and these rail cars, they're going, and it's just a non-stop. It goes all day, all night.
When the ladle comes out from the electric arc furnace room, it'll be filled up with steel, and that steel just has a little bit of alloy in it. The crane will pick it up, it'll take it over to the ladle metallurgy furnace we call the LMF, and then the operator will hook up their argon lines so they can stir the vessel, the ladle, and then they'll take a sample so they can get the chemistry of the steel. And with that sample analyzed at the chem lab and transmitted to them, they can see what the composition is at and then the recipe for the grade of steel that we're going to make on the screen in front of them. Picked that ladle up, moved it over, and then poured some of the slag off. And the slag is basically the thick, crusty layer on the top that's formed from the addition of lime and magnesium oxide or dolomitic lime that helps pull out impurities like phosphorus and sulfur, mainly sulfur at that stand. And we pour that off. Well, if you make a good slag, you make a good steel. So controlling the slag chemistry and making sure that it has the capacity to pull the non-metallics and some of the sulfides and phosphate and things like that. So working that is important, and then when we pour that off, and then go to cast it, that steel flows out of the ladle into the tundish, and then out of the tundish into the mold. That steel hits the mold, which is basically a big hollow copper device, copper shell, water cooled, that oscillates up and down, and so that liquid steel hits the mold, it solidifies around the outside, so it's a solid shell with a liquid core, and as it's pulled through the casting machine, that's probably some of your contained magic, where out of the bottom comes solid steel.
And so, as a planet, as we move towards decarbonization and the goal of net zero by 2050, there's going to be a greater move in other parts of the world to also increase the use of electric arc furnaces. So there'll be greater investment in the EAF technology to bring up to similar rates as in the U.S., and therefore the demand for recycled materials is only going to grow. And so it becomes so important that we work together across the entire economy to make sure that we are collecting, processing, and creating those commodity-grade recycled materials that are desperately needed for manufacturing to help reduce carbon gas emissions and to create a more resilient planet.
So, before we move down to the next part of the steel making, I'm just kind of sitting there stunned, trying to put my thoughts together of what I just witnessed. And there's no clarity, because I'm just all in my head. I'm getting all these different images that I saw that were it's just incredible. You can't make it in a movie from a set. You have to be in the real thing. And there I am. Go, no, wait, what about this? And no, what, no. And my mind is just going 100 different directions to trying to recap what the hell I just saw. Seeing it and feeling it from the ground floor. And I know I've seen the video of it. My mouth is, my jaw's dropped. It's the most incredible thing I've ever witnessed. I saw that, man. I saw that little baptism by fire. Well, when they opened up the saucer, when Flying Saucer came out, I never felt heat like that in my entire life, ever. I mean, yesterday and all, I was sitting there going, oh my God. And Tony goes, you get over there. Matt, what was your feeling? I don't even.
Yeah,
Hurry up.
that's right. Yeah,
Hurry up.
yeah. You had that week. Yeah, I remember calling.
It's just like it was like, all I couldn't wait is to do this, because the storytelling and they, setting it up with Alter, with watching the shredder operate, and the way, the access that we got, and just how everybody was just so, hey, welcome, let's do this. And then today, welcome, we're doing this. I haven't felt heat. The only time you ever feel heat is if, this may sound crazy, but when I put my arm inside the pizza oven when I'm at events. But, the pizza oven's 600 degrees, right? But I've never felt heat on my face and on my body at the level which up there on that catwalk above the molting of slabs. It's incredible. And what's so cool is seeing how real steel is made in respect to, we see it in our everyday lives, but seeing how it's made, what an appreciation, it's excitement. I felt so energized today that my heart was racing with excitement. I haven't had that sensation. I don't remember the last time I had it.
Coming up on the next episode of Repurposed.
SSAB is at the forefront of fossil-free steelmaking process. And then here we are, we're supplying steel also to a windmill to produce renewable electrical energy. So if you look at that, it becomes like a circular economy.